Yes, one node is visible to all. Confirm anyone?
Yes, sir. Visual.
Yes, sir.
Oh, fine. Okay, so today class is scheduled because of some out of station. So in online classes I can take anywhere, so it's not so big issue. Okay, so I'm not in Raipur, I'm in the Prayagraj actually. So tomorrow class is from the Raipur, and today I actually the train time exact at the 3 p.m. Due to that, so I rescheduled the time in morning time. Okay, so today we are going to start the asymptotes. So I think you know about the asymptotes. Asymptotes is what it is the straight line. Okay, uh, so that straight line is going to touch the curve at infinity. Means that they will not intersect each other. Okay, so it's looking lines. It tends to touch at the infinity as we move. So so there are three types of asymptotes. Uh, we can classify. Like first is the asymptote is parallel to the x-axis, and other one is the parallel to the y-axis. Okay, or you can say the perpendicular to the y-axis, x-axis, like in similar way. And other is not always we find the straight line always perpendicular or parallel to the x and y axis. We have oblique straight lines. Okay, so in the some places the straight line is oblique line is not
Sir, screen is not
It's not
visible.
visible.
okay. Is green just a second. I'm not writing now. Actually, I'm admit some students. That's why it's let me do something. Okay, now it's
So
come.
now it's visible.
Ah, yes. No, actually, to admit the student now, so it's going background. So that's why it's not coming. It's taking blank. So for now, 69 and 68 students have joined. Okay, so I'm telling about the asymptotes. I think you know something about the asymptotes. Okay, so this is the starting of before actually in the last lecture I said the curve tracing. So this is the one part of the curve tracing. There you need to find the asymptotes by which you can trace the curve. Okay, so today I think only we do the asymptotes. Okay, from the tomorrow we will start the curve tracing. Okay, let me admit some people. Okay, someone join. Asymptotes. So asymptotes is next to definition required. Okay, I'm just writing. System asymptotes is a line that approaches closer to a given curve as one or both of x or y coordinates. Means this is the book language tends to infinity, but yes, Priyansu, have you raised your hand? Any question?
No, sir.
Oh, fine. But never, as I said, intersects. Sorry, intersects or process the curve. So the types are here. So we can write here the types are what oblique, and second one is the oblique. So there are the two types of asymptotes. Okay. So when we are coming to the horizontal case, means just example. Oblique case we can show like if we say the straight line. Draw. So it's like curve is I want to shoot speaker one. If something is going on this manners, or like if something it is, so this is the asymptotes. So these asymptotes which is parallel to the x-axis or perpendicular to the y-axis, and this is also asymptotes. Okay, so these are the case for the rectangular asymptotes. Okay, in oblique asymptotes we can see just as a similar way. We can draw in the same manner. Draw like one straight line. We can take this as asymptote. The curve is like draw it's like this manner. This. Okay, so okay, curve is not is going smooth by hand actually. So you understand that the things. So here asymptotes not only the this straight line, this oblique one. And this is also called x-axis also becomes the asymptotes of the given curve. Okay, because in both side it's going to touch the curve. One more famous you can see here, this is the normal curve that you are going to understand in the fourth semester. You study the normal distribution. It is very important because the grading system, all the things is based on this curve. Okay, so this is also normal curve which is tends to touch the x-axis. Okay, now here the questions may come. So find the asymptotes of the. Actually, this useful while tracing the curves, not different. Maybe in objective type question MCQ is maybe different, but it is very useful in tracing the curves. That is the part of that one. Okay. Now we come to. So method to find the method of finding rectangular asymptotes. Method of finding rectangular asymptotes. Rectangular asymptotes. So first to find asymptote parallel to x-axis is to find as asymptotes parallel to x-axis equate to 0. Coefficient of highest power of x in the equation of curve. Okay, I directly written because not because you know that things any curve is represented by some polynomials, a function of xy. Okay, is equal to 0. Function of xy is equal to 0. So what happened? You just separated all the terms and what the things to find the asymptotes parallel to x-axis. Parallel to x-axis. Okay, means perpendicular to the y-axis. Equate to 0. Equate to the coefficient of highest power of x in the equation of the curves. Okay, coefficient of that coefficient may be coefficient, that means not only the constant term but maybe the variable y, other variables. Okay, so you will get the equations of y equal to 2, y equal to 4 something, y equal to some constant value, so that is parallel to the y axis, parallel to x axis. Okay, so to find the asymptotes parallel to the x axis, you have to equate the coefficient of the x, highest power of x, highest power. Okay, there may be present x cube, x square. So you just choose the highest power, equate to the 0. You will get the asymptotes uh, to the curve, which is parallel to that one. Next, similarly, if you going to find the asymptotes parallel to the what y-axis, equate the coefficients of highest power of y to the 0. Similar manners. Okay, the equation of curve will directly come to the problem. Just writing the points is important to remember. Suppose sometimes to find as asymptotes parallel to uh, x-axis. What I written here? X-axis is equate to 0. The coefficient of highest power of y in the sorry, highest power of y in the equation of curve f of x y is equal to 0. Okay, okay, just a second. Yes. So this is the okay. So for example, like question, find the asymptotes to. The question is like that: 4x square, very simple one. 9y square is equal to x square y square. So in this case, you take it out at one side. 9y square minus x square y square is equal to 0. Okay, so we need to find the asymptotes. What will the asymptotes is parallel to y-axis and x-axis. You can see here the power of x is 2, is the maximum in this equations. Now you take it, you can write in this manner: 4 minus y square into x square plus 9y square is equal to 0. Now the coefficient of x square is what is equal to 0. This implies that 4 minus y square is equal to 0. That means y is equal to plus minus 2. So this is your asymptotes. Okay. Similarly, the same, we are coming to the uh, so this asymptote is parallel to x-axis. Now 4x square plus, now need to,
Sir,
yes, yes, yes.
okay, for parallel to if you need to find the vertical asymptote parallel to y-axis,
Hmm.
I want to ask, why do you plug 4x square and x minus x square y square? We should plug 9y square minus x square y square.
9x square, uh, what, so coefficient of, why we are again clubbing this one, 4x square plus, we are going to do that one. This is the asymptotes, two asymptotes, we got it. Now again we are coming from the same equations, 4x square. Now we are taking the common y square. 9 minus x square y square is equal to 0. So again, coefficient of y square is equal to 0. Okay. So now what? 9 minus x square is equal to 0. So this implies that x is equal to plus minus 3, which is parallel to the y axis. Okay. So we have, so there are four asymptotes. Four asymptotes to the given curve. So in MCQ, maybe asks how many asymptotes to the given curve, including oblique. So here we are not get the oblique because it is not the type of that problem. Okay, suppose I given one general means I will see the examples. We ask how many asymptotes to means how many asymptotes to the given curve. So if I ask only how many, so you include both x-axis, y-axis, parallel to, and other is also oblique. We ask only the parallel to the x-axis. You just include that, calculate in that manner. So just coefficient of x, you will get the parallel to the x-axis. If you only ask y, so parallel to in that manner. You just so it make question come in your MCQ such time. Okay, yes, sir. You were asking something. Why we are not club something?
Yes, yes, fine, fine. We can
Okay,
go for it.
okay. Now, now we are going to do for the oblique asymptotes. The oblique asymptote is what? This little bit has some calculation. Okay, but I'm going to write a working rule, so steps. So by following that, you can easily find the asymptotes which is oblique. So parallel is clear. So x and y axis. So most important is here oblique. So oblique is what? In this case, polynomial sum numerator denominator case. Okay, we discussed the problem directly here. It's me. Method of finding oblique asymptotes. So oblique asymptotes, obvious we have to assume that the equation of equation. So okay. So let asymptotes be y is equal to mx plus c, and let the equation of curve we can assume like this way: x y phi of n minus 1. This is plus sign, x comma y plus n minus 2 x comma y, and plus phi 1 of x y plus k is equal to 0. So very general R. So this is the polynomial is first find representing that will be the combination of x y. So the degree is n. Okay, total degree, or we can consider the degree of x is n. Means the total combination is degree is n. Okay, so in this case, what we do, we have to assume the values to find the asymptotes. So we can put here because we have to transfer this. The one the method is the one method is met. So in this case, we have to assume x is equal to 1 and y is equal to m, small m. So now this become the auxiliary equations. Okay, already discussed in the past. Sorry, three. Sorry. Okay, so auxiliary equation. By this auxiliary equation, we find the roots of these equations. That means you will get the equation of m, and you will get the some roots. And based on the roots, you can you can find the oblique asymptotes by the some equations further. Now I'm writing the steps here. Step one. Step one is what? Put x is equal to 1. Okay, y is equal to m, in phi of n x y y x minus y dot dot up to here you have to put. Second, step 2. Step 2, find all the real root. Find the real roots of yn of n is equal to 0. Okay, find all the real roots of phi nm is equal to 0. Okay, if dash, okay, we have to find. So what happened in this case? So it has the some repeated root, non-repeated roots. According to that, the step number 3 we are going to write. Okay, because if the roots are all distinct, so in that case, we can decide their equation of asymptotes. So find all the real roots of phi. Next steps 3. Step 3, if m if m is a non-repeated root, then corresponding value of c is given by c phi on dash m plus. Okay, so you have to write in such n minus m is equal to 0. Okay, one more thing. Phi. This is the actually first we have to write the things complete, which is not equal to 0. So if m is non-repeated root, then corresponding value of c is given by, means because oblique roots is y equal to mx plus c. Okay, already we assume that, let the asymptote be y is equal to mx plus c. So by the auxiliary equations, we can find the value of m, that is give the slope of the asymptotes, and next we are going to find the c intercept, that c is calculated using this expression. C is equal to phi n dash m plus phi n minus m is equal to 0. That means what the powers of phi n. Okay, so derivatives of that one we are including, and we are equating to 0. So then we find the value in this. Okay. So maybe there is the things, if suppose phi and dash m is equal to 0, then there is no asymptotes to the curve corresponding to this value of m. So what happens if phi and dash m, so to the highest power, there is means is equal to 0. So then there is no asymptote to the curve corresponding to this value of m. Okay, because we are unable to find, that means okay. So next is what you can see in the step number 4. If m is a repeated root occurs twice. If m is a repeated roots occurs twice. Okay. Well, means if any root is repeated twice. So then there is the case, then the two values of C are given by, so roots are when repeated, so that means is what, so for C will different, so that means C is, now we have to consider quadratic equation. If two times repeated, then three times repeated, then we form the cubic equation of C for the intercept case. Okay, so now we am writing the because it's twice. Okay, roots are repeated twice. So in this case, C square upon factorial 2. Okay, these are some, the proof is available in the books, but not we discuss because of we use only application part, means only formula. Dash n minus 1 m plus n minus 2 m is equal to 0. Okay, we're writing the bracket m, that means that is the function of m, and phi suffix n minus 2, that is the degree of m. One more thing, in this case also we can, in this case it should be phi double dash m should not be equal to 0. Okay, step number 5. So after finding the C, the asymptotes of the curve is y is equal to mx plus c. Okay, so this is the asymptotes of the curve is y is equal to mx plus c. Okay, that's it. You have to do like this manner. So only here we retain the. Okay, one more thing. Suppose there is the three times repeated. So in this case, I want to write something to, if a root is repeated three times, then then the three values of C are given by C cube upon factorial 3 pi and dash triple dash m plus 3 times derivatives C square upon factorial 2 phi n minus 1 double dash m C upon factorial 1 phi dash n minus 2 m, and last is uh, n minus 3 m is equal to 0. Okay, so you will have this. Now we come to the problem directly. Okay, question: find the all asymptotes of the curve. The equation of curve is now looking like something bigger. X cube minus x square y minus xy square plus y cube 2x square minus 4y square plus 2xy plus x plus y plus 1 is equal to 0. Okay, you see this equation is little bit looking like longer polynomial. Now, so what you do, so it is also in that order. The x cube minus x square y minus x y square. The orders first is the we have to rearrange y cube can be written. So 2x square minus 4 2xy like that. So in this case, in this the highest degree containing the term x cube. Okay, and its coefficient is 1. Okay, so that means no asymptotes parallel to 1. Highest degree is what? Cube is there. And coefficient is what one you can see here. Is any present other x cube not present? Okay, so when you're equating to the 1, so in this solution, highest uh, degree term of x is x cube. Coefficient of x cube is equal to 1 means 0. That means 1 is equal to 0. This implies that no asymptotes parallel to x-axis. Okay, if suppose while solving the problems you should write the things. Okay, no asymptotes. Similar manner, if you are getting highest degree term is y cube and other no there is the y cube, again the same things. Similarly, coefficient of y cube equal to 0. That means 1 is equal to 0. So this implies that no asymptotes parallel to y-axis. This done. Now we are coming to the oblique curve. So while oblique curve finding, so we going through that steps. Means you now we take here what the expression take x is equal to 1 and y is equal to m. So this convert auxiliary equations. Okay, so we can say this equation is 1. Okay. In equation 1. So then we have while taking so we have the equations like m cube minus m square minus m plus 1 is equal to 0. Okay, we are getting this one. Yes, anybody confirm it if you're
Yes, sir.
writing this.
Yes, sir.
Okay, you see this one. So x is equal to what? Means x is equal to 1. So this is 1. Okay, minus x square means m minus 1 into m square m cube. Okay, and similarly this become the 1 and after that the simplification. Okay, so we will arrive this m cube minus m square minus m plus 1 is equal to 0.
So 5m square 1 minus 5m square.
Yes, sir. 1 second. Huh. No, that is 5m square. Okay. So here, what we have done actually, listen, one thing I have not written. That, if I take in 21 equations 1, we have, this is, I'm writing for this one, 5, 3m. 3m, that means only 3 degree terms, combination of x and y. Okay, so first one is 1, means we are including in this case, actually directly first we write, then we separate the 3m. So this one, this is become 1, and this is also the total degree 2 and plus 1 is 3. So now this is minus m, and this is minus m square, and this is m cube. So that terms we included in this one, 3m, the 3 degree terms here. Okay. As you see in that, the different the method, the highest means combination we take is, we not take the all one. Okay, that's by mistake I said that. We can, this is the 5 3m, only this one. Now we are there, factorization, we do the factorization. So we will have m square minus 1. So m minus 1 is equal to 0. This implies that m is equal to 1 and minus 1. So here the things is what, the roots are repeated. So roots are repeated here, and this m is equal to 1 repeated 2 times, and m is equal to minus 1 non repeated. Fine. So for m is equal to minus 1, so in this case c, we find the c here, phi 3 dash m, okay, plus phi 2 m is equal to 0. Now see that one, phi 3 m, the first derivatives. Okay, so already phi 3 m we have taken here. This one, m cube minus m square m. So when you take the derivatives, so we will have what, c 3m square 2m minus 1 plus, and phi 2m, this we calculated from this one. Phi 2m include this term up to here. This is incoming phi 2m by taking, this is what, xm. So we writing in terms of 1m. So this 2 means we can write here. Okay, let me write. We write here that 2 plus 2m minus 4m square is equal to 0. Okay, this implies after that c is equal to 2m, so negative terms. Okay, we adjusted there, minus 4m square minus 2, which is divided by 3m square 2m minus 1. This is c is equal to, and after that we put the value of c, m. We take here m, so this is 4 upon 4 is equal to 1. M is equal to minus 1 when we take. So we are getting oblique, therefore oblique asymptotes y is equal to uh, y equal to mx plus 1. This is the one asymptotes. Okay. So next is what? Similarly for the m is equal to, sorry, 1 1 1 comma 1. In this case we have to move the we need the c square factorial 2 and phi 3 double dash m plus c factorial 1 phi 2 dash m plus m is equal to 0. Okay, so I'm directly writing here c square by 2 phi 3 double dash m. Okay, double dash means again we differentiated, so we will have the same term. You can see there.
6m minus 2.
Yes, 6m 6m minus 2. Okay, c into phi 2 dash. So double phi 3 double dash 6m minus 2 is correct. Phi 2 dash is
Minus
2
4m
minus.
plus 1.
Yes, correct.
Yes, sir.
And phi m 1 plus m is equal to 0. So this implies that after that you have to simplify by taking the m is equal to 1. Okay, so we'll get the things. Okay, we take here m is equal to 1. So therefore the equations now c square minus 3c plus 1 is equal to 0. Okay. So see the cubic equations now. We can find here 3 plus minus. Okay, so we know by the 3 plus root 5 by 2 comma 3 minus. These are separate. So y is equal to is mx plus, so 3 plus root 5 by 2, another one y is equal to 3 minus root 5 by 2. So there are total three asymptotes. Okay, total, and the equations are this one. This three you can write in the below. Okay, this is your final solution of asymptotes. So in semester, generally offline class, offline exam may ask this question, but online classes is less chance because the question number is reduces due to we generally ask the stress. Okay, that include the asymptote terms in that case. Okay, we discuss the more one question the next class actually. Okay, so I think you have another classes. So okay, thank you for students who have cooperated me. This one means I have taken the next means at the 3 p.m. class in morning. Okay. If you have any doubts, you can ask me tomorrow. No issue. And so we will meet at timing of the class 10:30. So any questions? Anything?
No,
Okay.
sir.
Okay. Tomorrow we'll discuss more questions. So one or two, then we start the trace. Okay. So those who have attended the class, please mark the attendance within the time 10:30.